Alright, in this video, we're going to go over rationalizing technique. So when you're going to use the rationalizing technique, is going to be used to find the limit when you have square roots or radicals. So recall that rationalizing, we're going to do it by multiplying by the conjugate. So we're going to multiply both the numerator and denominator by the conjugate. What that means in this case is the square root of x plus 1 plus 1. So that's what we're going to multiply both the numerator and the denominator. So we're going to start off with plugging in 0 just to show that direct substitution won't work. So for this problem right here, we plug in 0. And then plug in 0. We see that we get 1. Square root of 1 is 1, minus 1 is 0. We get 0 over 0. So direct substitution right here we see doesn't work. So we're going to use this technique to help us find the limit. So this problem right here, we're going to go ahead and multiply x plus 1 minus 1 over x. And we're going to multiply that by x plus 1 plus 1 over x plus 1 plus 1. So notice how I'm multiplying by the same thing over the same thing. So this is technically 1. It's a convenient form of 1 that we can multiply to this problem. We don't change it, but we are going to change the way it looks so that we can start solving it. So once we do this, we notice that we get this radical times this radical is just going to leave us with x plus 1, and 1 times negative 1 is just going to leave us with negative 1. So remember that normally we have a binomial times a binomial. This is a difference of squares, so we end up with this right here. Similarly, for the denominator, we're going to end up with x times x plus 1 plus 1. Okay, so we have this so far. And now we're going to go ahead and simplify. So we simplify, we see that, let's go ahead and multiply this out right here, or actually subtract 1. So we're going to be left with x over x times square root of x plus 1 plus 1. So notice that the only thing that I did here was subtract 1 from this expression. And here we see that we build a big 1, or cancel out the x's. We're still left with a 1 in the numerator. And now we simplify and we get 1 over the square root of x plus 1 plus 1. Okay, and for this one, we can go ahead and try direct substitution. So now we can say the limit as x approaches 0 of 1 over x plus 1 plus 1. So here, once we plug in 0, let's go ahead and see now what we get. Plus 1 equals, and this is 1. So we're going to get 1 over 2. Okay, so here we see, sorry about that. So here we see that when we plug in 0 now into this expression, we can actually use direct substitution and we get 1 over 2. So the limit as x approaches 0 is actually 1 over 2. All right, now in your homework, you guys will have some problems that tell you to find an equivalent expression. So let me just show you what they mean. So if we go to the book here, and here it says, identify another function that agrees with the given function at all but one point. What they mean by that is pretty much just come up with something like this. Okay, so this is another expression or function that is the same as what you started with. It's going to be giving you the same outputs except for when x is equal to 0. Over here we see that we can't figure out what y is when we plug in 0, but for this equivalent function we can actually figure it out. So this one is the same thing as this function, and it's going to behave the same way except for at 0 we're going to be able to find an answer. Okay, so that's what they mean in your homework, just to keep that in mind. So this is the rationalizing technique, and you can go ahead and use this for the other part of your homework.